Welcome to the video presentation of computer number systems. We're going to cover decimal, binary, octal, binary coded decimal, and hexadecimal. Here we show our decimal numbers, base 10, the ones that we use every day. We could count from 0 to 9. We have only those digits. So we would start off with 1 and then go to 9, and then we'd go to tens, we'd add another digit. 100, we'd add another digit, and 1,000 another digit. So once we get past 9, we have to carry the decimal to the next place. So here we have 634. We have ones, tens, and 100. So this is the system we use daily. Here we have binary numbers base 2. 2 to the 0 would be 1, and we only have digits of 0 and 1 to work with. So here's 2 to the 1, 2, 2 to the second, 4, then we have 8, 16, 32, 64, 128, and 256 for the value of each digit. Okay, if we take a look at this number, 1011 base 2, the least significant digit, LSD, would be the smallest. The most significant digit, MSD, would be the largest. And we have values of each column, 1, 2, 4, 8. And if we were to break down this number, convert it to decimal, we'd have a 1 times 1 would be 1. 1 times 2 is 2. Our third digit would be 0 times 4, and our last one would be 1 times 8. And we add those up, and they become 11 base 10. Here we have binary numbers base 2. And we have column weights. Here's 2 to the 0, which is 1. 2 to the first power is 2. 2 to the second power is 4. And 2 to the third power is 8. So each one of these columns are the value multiplied by what's ever in the box. So if we start at 0, everything's 0. We have 1 times 1 is going to be 1. 3 would be 1 times 1 plus 1 times 2, which is 3. 4, we have 4 value in this one, so it'll be 4. 6 is going to be 4 plus 2. 9 is going to be 8 plus 1. It's 9. 12 is 8 plus 4. And 15 would be 8 plus 4 plus 2 plus 1. Here we have octal numbers base 8. We count from 0 to 7. Other than programmable logic controllers, this is a pretty obsolete counting system. And we have our weights, and we're going to count from 0 to 7. Once we go to 8, we're going to need to move our digit 1, 0, not 10, 1, 0. And here we have 8 plus 2 is 10. 8 plus 6, which is 14. Once we go to 7, 1, 7, the next number would be 2, 0. Not 20, but 2, 0. Here we have binary coded decimal, or BCD. So this one just uses binary code from 0 to 9, and this is the numbers that humans like to see, decimal numbers, and this is used to drive 7-segment displays and other displays where we're using numbers to count without going into the hex or binary numbers. So this would be a decimal display code. Here we have hexadecimal numbers, or hex numbers, and we're going to, it's base 16, so we're going to count from 0 to 15 decimal, and we're going to go all the way to 9, and then after 9 we're going to use letters. 10 is A, then B, C, D, E, and F. F is 15. Okay, so when we're using hexadecimal, we're going to use a combination of numbers or letters. Here I'm going to give you a little sample of our binary counting challenge. So here we have 1, 0, 0, which is what? 4. So the next one would be 1, 0, 1, 5. 1, 1, 0, which is 6. And 1, 1, 1, which is 7. And then we go from 1, 0, 0, 0, which would be 8. Here we have 1, 0, 1, 0. So the next one would be 1, 0, 1, 1. And here we have 1, 1, 1, 0. So it'll be 1, 1, 1, 0, 1. So let's try it out. And I have no idea what this guy's doing over here in the corner. Okay, good job. Here I'm going to give you a sample of Octal Counting challenge. So we have 3, 3, so the next one's going to be what? 3, 4, 3, 5, 3, 6, 3, 7, and the next one's going to be what? 4, 0, 4, 1. So once we get to 7, we need to move that digit. So we have 1, 7, 6, so we're going to have 1, 7, 7, 7, and then we're going to have 2, 0, 0. And here we have 1, 7, 1, so we got 1, 7, 7, oops, 2. Good job. Okay, our last sample of the day will be hexadecimal counting. So here we have 2, 9. It would be 2A, 2B, 2C, 2D, 2E, 2F, and then 3, 0. So here we have 3FC, so it'll be 3FD, 3FE, 3FF, and then 4, 0, 0. 5, 2FE, 5, 2FF, 5, 3, 0, 0. So let's try it. Oh, good job.